Okay, calculus, we are back here. This is section 0.3, page 9. These are additional examples, so everybody should write these down here at the top. And for these 5, it is simply find the inverse of each function. So I have written you a different page 9, a new page 9 this year. These are 5 just like it, so make sure you have this down. Find the inverse of each function. So f of x is 2/3 x plus 4. Remember, f of x, same thing as right in y. For an inverse, we switch x and y. Remember, it's a mirror image over the line y equals x. That is an inverse. You know that from geometry, and we did inverses in, you guessed it, honors algebra 2. So I'm going to switch x and y. X and y switch. Now, x equals 2/3 y plus 4. Now I solve for y. Subtract 4, then I'm going to multiply both sides by 3 over 2. 3 over 2x minus 6. Again, you were given the function as f of x, so you're going to write f inverse of x is 3/2 x minus 6. Number 2. Again, look at the top one here. Okay, so again, y equals... So then switch x and y. You're going to have x equals 3 times the square root of 2y plus 5. Okay, then go about freeing that y. Divide both sides by 3. X over 3 equals the square root of something. Square both sides to get rid of a square root. When you square x, you get x squared. When you square 3, you get 9. I am also, while doing that, going to move the 5 over. X squared over 9 minus 5 is 2y. Divide both sides by 2. Now, when I divide both sides by 2, here's what I'm doing. First off, instead of writing y equals, I'm going to write f inverse of x equals. When this is like 1/9, when I divide it by 2, I'm going to double the denominator. So it's x squared over 18 minus 5 over 2. That's another way to write it. So you guys might write it as x squared minus 45 all over 18. You don't have to multiply this by 9 over 9. It's fine. This does look better than this. All right. Number 3, real easy. Y equals 4x minus 5. So x equals 4y minus 5. Add 5 to both sides, then divide by 4. F inverse of x equals x plus 5 over 4. I was subtracting 5. I'm adding 5. I was multiplying just x by 4. I'm now dividing everything by 4. You can see how they're inverses of each other. That answer, sorry, should make sense. Okay, so y equals, so again, I'm going to interchange x and y. X equals the square root of 4y minus 3 plus 5. Subtract 5 from both sides. Square both sides. X minus 5, all of it squared, is equal to 4y minus 3. Add 3 to both sides. Move me. Then divide by 4. Get rid of this. So f inverse of x is going to be equal to x minus 5, all of it squared, plus 3 divided by 4. Again, let's see what I was doing. I was taking the square roots. Now I'm squaring. Notice I was taking the square root of this. Now I'm going to square, something involving x and the 5, and the 3 is going to be on the outside now. I was multiplying just x by 4. Now I'm dividing everything by 4. You can see how everything's kind of the opposite there. Number 5, give myself some room. This is the more challenging one. All right, this would be the toughest one when I taught pre-calculus. The toughest one I would kind of give. So y equals, so I'm going to switch x and y. So now x is here, and instead of it being x and 3x, it's going to be y and 3y. I'm going to cross multiply. So that y plus 3 is going to remain here, but 3xy minus x is going to be on the left. You can move things to whatever side you want. I always try to have as few negatives as possible, so that's why I'm moving this x over here, so now it's positive. I'm moving the y over here, so now it's negative. First off, you can get the y's together. Anything with a y needs to be on the same side, okay? So that's what I did. Then I factor out the y that they have in common, leaving you with 3x minus 1. Then I divide both sides by 3x minus 1. F inverse of x is x plus 3 over 3x minus 1. If you would have move something over here, you would have had negative x minus 3 divided by, what would have been 1 minus 3x. You would have just multiply this by negative 1 over negative 1. You would have gotten, it would have looked like something off, but it would have been the same answer. Just everything opposite sign. Okay, so that is page 9, additional examples, and we're going to give 2 more here in this video. Again, additional examples for what you have in your page 9. This is new for everybody, so everybody write down. So given f of x is equal to 3/4 x plus 6, find f inverse negative 3, f inverse of 0, f inverse of 3, and f inverse of 9. First off, y equals... So interchange x and y. X equals 3/4 y plus 6. Subtract 6 for both sides and multiply then both sides by 4/3. Multiply by 4 over 3. Multiply by 4 over 3. Distribute time. 4/3 x minus 8 is equal to y. So f inverse of x is exactly that, 4/3 x minus 8. X and y values switch, so there is another way to do this, but I like just getting that inverse. All right, and then this is the inverse function. Plug negative 3 into it. Boom. Plug 0 into that. Well, if you plug 0 into it, it's negative 8. Plug 3 into that equation, and then plug 9 into this equation. All right, there you go. Again, there is another way you could do that, but I think that is fine. That's what I'm going to do here on number 7. Given f of x is the square root of x plus 4, find f inverse negative 4, f inverse 0, f inverse 2. So again, this is y equals the square root of x plus 4. Again, what is the opposite of taking the square root? It's squaring, so it makes sense that my inverse operation is a parabola, something that is squared. So x equals the square root of y plus 4. I'm going to square both sides. Subtract 4 from both sides. F inverse of x is x squared minus 4. So f inverse of negative 4. Plug negative 4 into where? This one. I underlined it there. Plug 0 in where? There. Plug 2 in where? There. All right, and that will conclude this video, I believe. Page 9 there, inverses. Again, these are all things you've learned in the past, so we can go sort of quick through this. And sorry about that. Folks, this is the Yakmath video signing out.